This is section 3.4, problem solving with two unknowns. When you have two unknowns, you have to have two equations to solve them. So we're going to have two variables, and we're going to use two equations to help us solve them. So each one of these is going to create two equations. So the first one, example 1, says last month, Ty worked 24 hours more than Brittany. That's one statement. The other statement is that together they worked a total of 280 hours. Find the number of hours each person worked last month. So we have Ty and we have Brittany. Now you can use whatever variable letters you want, but to me it makes sense to use T for Ty and B for Brittany. You want to use letters that make sense so you don't lose track as you're going. So the first statement, Ty worked 24 hours more than Brittany. So Ty's hours equal 24 more than Brittany. Brittany's hours plus 24 will give you Ty's hours because he worked more. It says together, that would be Ty plus Brittany. Together, they worked a total of 280 hours. So we have two equations, one from each statement. We have to solve for both unknowns. It's impossible to solve for both of them at the same time, so we're going to solve for one variable at a time. And the way this works, this is weird at first, and it will make more sense as we go. The first statement says T is equal to 24 plus B. So the expression 24 plus B is the same as the letter T. So what we're going to do is take the first equation and substitute. This is called substitution. We're going to take the T out of the second equation and replace it with the expression that it's equal to. So we're doing what's called substitution. We're combining the two equations so that we can solve for one of the two variables. So the second equation, let me see if I can do this right, is going to look like this. Instead of T, we're going to put what T is equal to, 24 plus B. So what I did right there is take this T, you're going to replace it with 24 plus B. The rest of the equation stays the same. So what we do is we have two separate equations and we combine them by taking one of the letters out and replacing it with its equivalent expression. What that does is create one single equation, and if you notice, now I only have one variable to solve for. So we can't solve for both at the same time. We're going to choose one, in this case B. We're going to solve for B, and then we'll use that answer to figure out T. So you can only do one at a time. So what we have is 24, then we have plus B and plus B again. So that's plus 2B equals 280. So now we're going to use our solving skills. Subtract 24. And that's going to give us 2B equals 256. And then divide by 2. Let me work that out real quick. And B would be 128 hours. So those are Brittany's hours. So we use the letter B to help us remember that those are Brittany's hours. That's only one answer. When you have two unknowns, you're going to have two answers. So now that we have Brittany's hours, we're going to go back, and I usually use the easier looking equation. This one's a little easier to work with, to figure out Ty's hours. So T equals 24 plus, we just figured out Brittany's hours, plus 128. So T equals 24 plus 128. Is 152 hours. And so you're going to have two answers. So that's your second answer. So you're not done with the first. You have to get both answers, Brittany's hours and Ty's hours. So it's going to ask for both for these problems. So these get a little messy, as you can see. You have to really keep up with where you're working. I got a little all over the place. Color coding helps. If you notice, I use different colors to help keep track of everything. Give yourself more space if you need to. These can get pretty messy. But the basic steps are to create two equations. You can write those down at the top. You create two equations. You use what we call substitution, which you'll get used to. So you create two equations, you use substitution, you solve for one, and then you plug in for the other. So those are just generic. They're very generic steps. Create two equations, use substitution to combine the two equations, solve for one of the variables, and then plug in to solve for the other variable. Those are the basic 4 steps. And if you can figure these out without the two equations, you are more than welcome to do so. I find that creating the two equations is the easiest way to get to the answer. So let's look at the next example. The length of a rectangle is 8 centimeters more than the width. That's our first statement. The perimeter is 76 centimeters. Find the length and the width. I like to draw pictures, so I'm going to draw a picture here. The length is 8 more than the width. So the length is 8 more than the width. So I'm going to use L for length, W for width. And it says the perimeter is 76 centimeters. It doesn't say anything about the width, so I'm just going to use W for the width. Excuse me. I know the perimeter formula is 2L plus 2W. So my two equations that I'm working with is that the length is 8 plus W, and that the perimeter is 2 times the length plus 2 times the width. So we're going to combine these two equations. The perimeter I know is 76. So 76 equals 2 times, now instead of using L for length, I'm going to use what it's equal to, 8 plus W. So I'm going to substitute in 8 plus W for L. So I took what L is equal to and I plugged it in to the equation using the perimeter equation. The rest of the perimeter equation is plus 2W. So instead of 2L plus 2W, I use 2 times what L is equal to plus 2W. So I'm using the perimeter equation and combining it with the statement they gave us for length. And to me, that's the hardest part, is creating the two equations and then combining them into one. From there, you solve for one of the variables. Let me use the same color scheme here. So I'm going to distribute that 2 and use my solving skills. 76 equals 16 plus 2W plus another 2W. So 76 equals 16 plus 2, and 2 makes 4W. Subtract 16. So again, the solving should be relatively straightforward now. So 76 minus 16 is 60, equals 4W, divide by 4. W equals 15. So we have one answer. we're going to use that one answer to plug in to get the second answer. So I'm going to take that W and plug it in to this equation. I'm going to put it over here. L equals 8 plus, we just figured out that W is 15. 8 plus 15 is 23. So there is my length. So you have your length and your width. So you have to have your second answer. So there's always two answers for two unknowns. Length and width, Ty and Brittany, whatever it is, there's always two answers. So these get pretty intense. These are very long problems to work out. You really want to make sure you follow your work. All right, example 3, a fence is 706 meters long and is cut into 3 sections. 2 sections are the same length, while the third section is 25 meters longer than the one of the equal length sections. Find the length of each section. So this textbook really likes these problems. I'm going to draw a little picture to represent the fence. It's cut into 3 sections. They're not of equal length, right? So they're kind of off. 2 of them are the same length, so I'm going to use X and X. The third section is 25 meters longer than one of the ones with equal length. So 25 plus X. So there's 2 that are the same, X and X, and 1 that's longer, 25 plus X. All 3 of them together add to 706 meters. So this one's solved a little bit differently. Drawing a picture is what kind of gets you your equation. So our equation this time is a little bit more straightforward. This section plus the next section plus the third section equals 706 meters. So it's just first section, second section, third section. We combine like terms. X plus another X is 3X plus 25 equals 706. Subtract 25. 3X equals 681. And then divide by 3. Let's see, 681 divided by 3. X is 227. That's one answer. So those are the 2 sections of equal length. 2 sections are 227 meters long. The third section is 25 plus 227. So the third section is 252 meters long. So there's 2 answers, but it covers all 3 sections because 2 of the sections are the same length and the third section is a little bit longer. So students generally find the fence problems a little bit easier to work with. There's no substitution for these. I just draw a picture, set up my equation, solve for one variable, and then plug it in to solve for the other. So these are generally a little bit easier to work with. All right, so those are the basic types of equations you're going to see for this section. The second set of examples 4, 5, and 6, are relatively similar to the first 3. If you'd like to pause the video and try these 3, otherwise you can just watch me work through them. So let's look at example 4. It says, in a day of work, Philip made $12 more than his brother Robert. Together, they made $282. Find the amount each person made. So Philip, I'm going to use the letter P. Robert, I'm going to use the letter R. So Philip made $12 more than Robert. Together, they made $282. So here are my two equations. $12 more than Robert. Philip plus Robert equals $282. I'm going to use substitution here. I'm going to take 12 plus R and plug it in where I see Philip. So 12 plus R plus the other R from here equals 282. And that's easier to see if you color code. We took 12 plus R, we replaced P with 12 plus R because that's what P is equal to. And then we can solve. We have one R and another R, so 12 plus 2R equals 282. Subtract the 12. 2R equals 270. And then divide by 2, divide by 2, and that's 135. So Robert made $135. That's one answer. Now we need to take that answer and plug it in to get the other answer. Philip is 12 more than the one we just figured out, 135. So Philip made $147. And here's our second answer. So again, there's always two answers for these. Alright, next example. Charles has 175 yards of fishing line to put on 2 fishing reels. He puts 25 yards less of line on one reel than the other. How much did he put on each reel? So we might want to call this, I might call this reel A and reel B to keep them clear. So together he put 175 yards. So A plus B equals 175. 25 yards less on one reel than the other. So let's say A equals B minus 25. So 25 yards less. So whatever he put on B, he put 25 less on A. And it's okay if you put A and B. That I just arbitrarily chose those two letters to keep the two reels straight. So together they have 175 yards. One reel is 25 less than the other. So we have our two equations. I'm going to use substitution. I'm going to take B minus 25 and replace where I see A in the other equation. So I'm going to have B minus 25 plus B equals 175. And again, color coding really helps here. B minus 25 replaced the A from the top equation. And then I go ahead and solve. So we have B and B, that's 2B minus 25 equals 175. Add 25 to both sides. That gives us 2B equals 200. Divide by 2, divide by 2. B equals 100 yards. So one of the reels had 100 yards. And now we need to go back and solve for the other. We know that reel A had 100 minus 25. So reel A had 75 yards. And here's our second answer. I'm going to pause there so that the video does not cut off, and I'll finish with example 6 in just a second.